I was going to cover the subject of novel or alternative crops within beef and sheep production systems. Effectively, there is a huge range of alternative or novel homegrown feeds available for us to use within the UK. Just a few of the examples are given here. Now, obviously, in the time that we have available this evening, I'm not going to be able to cover all of the research we've done across this whole range of feeds, but I am going to give you some examples. What I've selected out is some experimental work which covers a demonstration really of the value of these homegrown feeds in how they can improve livestock performance, improve nutrient use efficiency, and also maintain animal health. I'll give some examples of some so-called bioactive forages that are able to do that. And really just to demonstrate how by increasing the range of homegrown and novel feeds we use, we can develop more sustainable agricultural systems. Now, before I go on to the range of the things out there, I did feel I had to mention them as the number one and not to be ignored is the grass. So please don't think that I'm dismissing grass just because I'm going to not cover it in great detail or use it as what I'm going to call a control within this talk. Obviously, grass represents 90% of the land area in the UK and 60% of that grassland is farmed. So this is our major commodity, and it is indeed this commodity that makes the UK a world-renowned producer of the top quality beef, lamb and dairy products that we produce. But that said about grass, I'm going to focus then on some of the alternatives. The reason for this is, as you're probably all aware, ruminants are generally poor converters of dietary protein into muscle protein. So the forage protein that they consume and the conversion of that into muscle is a relatively poor ratio. And quite often, therefore, at key times, grass-based systems require the addition of concentrates in order to maintain viable productivity. Now, this reliance on concentrates is, well, we need to look at these alternative feeds in order to reduce this reliance, because we're currently importing 70% of the protein feed that we use within the UK agriculture, and 90% of these EU protein imports are in the form of soya, and the estimated figures at the moment are 1.4 million tonnes of it coming in each year. Now, soya is the main constituent within the dairy diets, with 53% of concentrates being used with the soya, and in the case of sheep and beef, it's generally in the form of proteins in the form of palm kernel or oilseed rape, not all UK sourced. So we're really looking for more traceable, more homegrown, non-GM feed to meet consumer demands for animal products. So what I was going to just do is introduce you to a few of the forages that I'm going to talk about within an experimental context. The first of which will be hopefully the most familiar is the red clover, which has a very acceptable level of crude protein at 21% and an ME value of 11. Now, the key thing with red clover, it can be grazed or it can be ensiled. In terms of its limitations, you need to be careful to not turn animals out onto this with empty tummies, otherwise you can get issues with bloat. It also needs to be rested over winter or lightly grazed over this time. And also, due to the presence of phytoestrogens and other compounds, it should not be grazed by use prior to and post-tupping. Okay, so that's red clover. The second forage crop that we've looked at is lucerne. Slightly higher dry matter than the red clover at 30%, but a similar crude protein content typically and similar ME value. The beauty of lucerne is that it is drought tolerant, something that we don't often require in the UK, but actually, as we know, this may become an issue in the future or in some of the summers we're having. So this is actually a key benefit of this forage over red clover. It's more suitable for cutting than grazing, and similar to the red clover, it should be just lightly grazed late autumn and then rested over the winter period. And last but certainly not least, there's the kale. Notably, the kale has a very low dry matter content at typically about 12%. Similar to crude protein levels to the previous crops, were slightly lower and similar ME. It's typically winter hardy, and it's, although it is mostly grazed, it can actually be baled. And I will talk about some research where we've done that. And a key limitation with it is some evidence that it can cause taint in milk when consumed in a high level of intake. Okay, so I'm just going to give one example of some work we've done which was actually DEFRA funded. And this was looking at ensiling these homegrown forages. We used sheep within the experiment as our model ruminant, and we produced the silages from the same field site with 0.5 hectare plots of the different forage species, as you can see. And we used a hybrid ryegrass as our control to compare these against. All of the forages were ensiled in bales after a 24-hour wilt, and then they were offered over winter periods to store lambs which were about 8 months old. So in terms of how the forages were accepted, just the other thing was that the other key part of the experiment we were interested in is how well the forages are utilised when they're actually consumed in terms of the nitrogen utilisation efficiency. So this is effectively how much of that nitrogen, when it's consumed from the forage, goes to produce nitrogen in the form of muscle protein. And in order to do this, we looked at the live weight gain of lambs and the feed intake of them on a group basis over an 8-week period. This is a graph of initially the intake levels of the animals. As you can see, we had significantly higher levels of intakes on a dry matter basis for the sheep consuming lucerne and red clover in comparison to the ryegrass and the kale. And indeed, the production responses were reflected in that in terms of the live weight gain, which for the top intakes there was about 135 grams per day. Now, looking at the kale, you would expect that actually, in terms of how well they utilise that forage, that actually wouldn't come out as well against the lucerne and the red clover. But when we actually did look at the nutrient use efficiency, so this is the live weight gain in kilograms per kilogram of crude protein that was consumed, you can actually see that the kale was the most efficiently used. And this was due to the energy-protein balance in that forage and that silage being more optimal for the animal than the other treatments. So things are not always as they appear from the intakes and the live weight gain. Now, another part of this experiment that we did, and I'd just like to touch on this because I feel it's quite often when we feed high nitrogen diets, high protein diets, as we know, if it's not efficiently converted into meat, then there's a risk of that coming out being of damage to the environment. But what we did was actually think about this as a most valuable asset on your farm. So if you have the slurries from animals fed on these protein diets, and assuming that they are stored and applied correctly and according to guidelines, then actually they can be used as a really valuable nutrient source. So what we actually did was collected the slurry from underneath lambs during that experimental period. And this slurry was then spread onto ryegrass plots in 4 replicated blocks. And we looked at how the slurries from these sheep were compared with plots which received either 0, 100 or 250 kilograms of inorganic nitrogen per hectare per year. All of the plots that treated the slurry also did receive a set amount of 100 kilograms of inorganic nitrogen as well, just to mention that. And then we looked at how dry matter yield given from those different treatments. So these are presented here in the graph here, where you can see we have the 3 control treatments to the left with the 0 inorganic nitrogen first, followed by the other 2. Now the black line that runs across the graph denotes the fact that all of the plots received that level of 100 kilograms of N. So what you can see as the effect of the treatment is what is happening above that line in terms of the yield. It's quite clear to see that the lucerne slurry was actually of higher value in terms of the dry matter yield of ryegrass that was yielded from that. And this was comparable statistically to plots receiving 250 kilograms of nitrogen. This was closely followed by the red clover, which was intermediary between 100 and 250 in terms of significance. And then the kale and the ryegrass were similar, but again, obviously slightly higher than the 100 they'd all received. The kale there is obviously again a reflection of the fact that nitrogen was utilised more efficiently within the animal and brought it closer to the ryegrass in that instance. So really just to try and realise the value of when we start to integrate these homegrown feeds within a livestock system, how we can use them to really build nutrients within a plant, animal, soil cycle and see them as integrating within managing the nitrogen within the whole farm system. Very important. Before I move off the subject, I'm just aware that I focused a lot on sheep there, although it was the ruminants, but we did also do similar work then on grass and red clover silage fed to Aberdeen Angus steers. This was a study by Professor Scollin, where we could show that in comparison to grass silage, when there was red clover included in the silage, we got a comparable production response to feeding grass silage and soya. Okay. Moving on to the other part of what I was hoping to cover today, which was to do with how you can use these forages to maintain or indeed improve animal health. I was going to look at just 2 examples of bioactive forages to see not only how you can use a nutritional approach to improving animal health, but also how secondary plant compounds present in a lot of these novel feeds can improve nutrition in ruminants. So the first of these that I'd like to introduce is chicory. Similar to kale, it does have a low dry matter, again at about 12%. Its crude protein is typically higher than ryegrass. It responds more efficiently to any inorganic nitrogen applications it receives than ryegrass from work we've done. And it also has a very acceptable NE value of about 12. The key thing with chicory is it's able to produce forage at the back end or the end of late summer and provide feed quite often for finishing lambs in that late summer gap or forage gap as it's referred to. And there's been lots of research that's shown that it does increase productivity in finishing lambs. That's been covered in New Zealand and in several studies here in the UK. And the way in which it's acting as a bioactive forage is it contains secondary compounds, includes several of these, but the main one is it contains sesquiterpene lactones. I'll just cover a little bit of how they operate within the animal. The key thing to note about chicory is it does need different management to ryegrass, and you do need to keep it in a vegetated state in order for it to provide the production benefits we're hoping to see. If it's gone to seed in a similar way to any other forage we consider and it's gone too mature, then you've lost those benefits. So I just wanted to mention that. The other bioactive forage I was going to introduce was birdfoot trefoil, quite often referred to just as lotus. Similarly high dry matter as we see in lucerne and similar crude protein to the other legumes, slightly lower ME. The thing with birdfoot trefoil is it's typically found as a primary invader species, so it does suit low fertility, quite acidic soil. And its limitations currently is that it's agronomically challenged, I think is the term. It suffers slightly from poor establishment. It's not very competitive during establishment phases, and because it is beneficial to livestock, they will preferentially graze it. So persistency is also an issue. But it does, where it does persist and it can be grown, there's evidence to show that it's very good at improving performance, and the plant compound involved in that is typically a condensed tannin that's present in the plant. So just to cover some of the work we've done with these in terms of how dietary control and health, we looked at the effects of birds foot trefoil and chicory on helminths, or the internal parasites in lambs. And what we did in this experiment was the lambs were just comparing parasites that they had were naturally acquired, so they weren't treated with parasites. And we collected, as animals were grazing pure spores of these, we collected fecal samples from them every week and did fecal egg count monitoring. And then as the lambs were ready for slaughter, we took post-mortem samples and determined their total parasite burden internally. So here's just results to start with the fecal egg counts from those. You can see over the 5-week period. What we have most notably was the yellow line at the bottom, the bird's foot trefoil. What we found was that pretty much the animals didn't actually increase their fecal egg counts as was seen on the ryegrass white clover control, but they very much plateaued out and remained at that level. The response to the chicory was slightly more delayed, so we didn't find that until about week 2 or 3 we started to get an effect on a lowering of that fecal egg count. These results were consistent. We repeated this experiment over 3 grazing seasons, so the data that I'm showing here is not seasonal effect. Some of the reasons why we got the fecal egg count data to be slightly delayed on the chicory might be due to the fact that when we actually looked inside at the total parasite burden, we had much lower levels of abomasum parasite, worm parasites, than in ryegrass. But when we looked at the small intestine, there wasn't the differences present. In comparison with bird's foot trefoil, which had lower levels in both the abomasum and small intestine compared to the ryegrass. So an immediate response on all the parasites present, and that was why that fecal egg count was reflected so clearly. Okay, so following on from that, the conclusion was that the bird's foot trefoil had the potential to reduce internal parasites in the growing lambs, but the chicory is only reducing the abomasal or the stomach parasites. So very good in one sense in terms of parasite control. However, we do need to overcome the agronomic performance of the bird's foot trefoil before it can be integrated fully on UK farms. So moving forward from this then, due to the production responses we'd seen in the chicory in terms of lambs, there was a study conducted in looking at the effects of chicory in beef steers. I should mention this was with other partners. And effectively what we were interested in looking at, obviously the performance of those animals over a typical 2-year beef finishing study. And we also monitored the parasites in these animals whilst we did the study, and then ultimately looked at carcass quality of animals grazing. So the experimental approach was to establish plots in the first year, and they were lightly grazed by lambs in order to get the particularly the ryegrass established. In year 2 then they were used for the experiment with steers' performance being monitored, and during that critical first grazing season when the animals are more susceptible to parasites, we monitored the parasites by fecal egg count. All the animals were then housed over winter and offered a ryegrass silage plus barley straw. before being put out onto the same treatment in the second grazing season, again monitoring performance and looking at the carcass quality as they were ready for slaughter. In terms of establishing the plots, we used triplicate 2-hectare plots for each treatment. We had a perennial ryegrass sown at 30 kilograms per hectare, and then the chicory, which was Puna 2, went in at 7.5 kilograms per hectare, and perennial ryegrass at 22. This is slightly higher than is used in practice, but for experimental purposes we wanted a really good take. So this is a photograph of those plots that were sown early June, just 4 weeks later, so the chicory came really well. The approach was we had 36 Belgian blue cross steers, so there were 6 animals grazing each of the subplots, and we monitored their live weight every 14 days. As I said earlier, in the first season, the parasites were monitored by taking a fecal egg count, and this was done immediately prior to any anthelmintic treatment, so we still continued to routinely treat the animals. In the second grazing season, then the steers were selected out for slaughter, and days to finish were recorded. They sent down with collaboration to Bristol University. We looked at carcass grades, live weight and coal carcass weight to determine killing out percentages. So in terms of performance, hopefully it's quite evident to see that there was no effect at all. So these are fecal egg counts taken at different time points over that first grazing season. The data is a little lower than you'd expect from a normal fecal egg count for the analysis, but there was no effect of the treatment on the parasite burden from the fecal egg count. When we looked at the live weight, I think you can clearly see if we tried to draw 2 lines close together, we couldn't have managed it. This is the live weight starting from day 0 with the first arrow as animals were turned out in their first grazing season, all the way through to housing. You can see there a typical dip as the animals are turned out at the start of the second grazing season and then continued together. The slight splitting there at the end is due to the fact that we only had 2 to 3 animals left prior to them going off, so that obviously gave this variation. So absolutely no difference in live weight gain for the steers between treatments. Looking at the carcass quality, there have been results showing that the lamb carcass conformation can improve on chicory, and we were interested to see if this was the same in the beef steers, but we didn't find any differences in terms of carcass quality. Certainly no difference in terms of days to slaughter as we'd expect in live weight gain, and no differences in killing out. So fairly easy to interpret the findings on that. The conclusions were therefore obviously with those no differences, we can safely say that there is no detrimental effect of including chicory on their performance. Obviously with quite a low dry matter that could have been the case. In terms of the parasites monitored by fecal egg count, there were no differences and indeed no detrimental effect on carcass characteristics. And that work's just, it's actually published online and open access if anybody wants to follow that up, it's in +1. Okay, so I hope I've given a snapshot view of some of the ways in which we look at a whole variety of different novel forages and the value of which they can provide when they're integrated into a ruminant system. Covered really just 3 very quick examples of how they can improve performance and health, how they can improve nutrient use efficiency, and I'll say it again, how they can improve animal health to build a more sustainable agricultural system. Thank you very much.
Thank you very much, Christina. As I said earlier, if anybody wishes to ask any more questions, please type them in. We will just start asking some questions, if that is okay. So just in relation to the chicory work, both from the beef perspective, we discussed at the time whether there would be greater differences if you had a pure stand of chicory versus grass?
Yes, and I think the answer to that in terms of probably from the lamb studies we did where we did have them on a pure sward, yes, we would. The concern at the time was if we had a particularly wet summer, which I think we've just had, then given the low dry matter of chicory, would the beef steers, particularly in the second grazing season, be able to get adequate dry matter intake that they required? So we went for a high sowing ratio of chicory to the ryegrass to see that effect. I think the key thing would be to look at, over a short grazing period, a performance response to a pure sward, where you are not dependent on that sward providing feed for a full 2-year beef finishing system. So that would be the next research to do.
And so one of the questions again on that particular trial was, did the parasitic burden come naturally on all the beef cattle grazing plots, or was it introduced? They were all naturally...
What we actually did was we turned all of the animals out onto a field adjacent to the experimental plots. So they were all kept as one group and naturally acquired parasites from that. We then monitored fecal egg count. So they were on that for 28 days, and then we started the experiment based on their fecal egg count. They were allocated, so they were balanced for fecal egg count at the start.
Perfect. And so also, just in relation to the chicory, so again, it's anecdotal evidence, but in terms of talking to someone from New Zealand that were encountering issues with worms while grazing chicory.
Mm-hmm.
So any thoughts on why that might be?
Well, the chicory, I mean, the work we've shown where we actually were able to get down to species and how they were changing within the animal, we only found that chicory was reducing parasites in the stomach. So if your animals are affected by other parasites, then it's probably not going to have a strong effect. It also depends on how those pathogens are probably managed. We did some studies which showed that the chicory will actually break the life cycle of the parasite, because obviously they've evolved for a ryegrass type mixed sward, and the chicory sward is quite different to that. So sort of if the pathogens were managed, maybe they would be avoiding that issue, but again, I would imagine that probably due to the fact it's only species specific or location specific, I think it's probably better.
We've got quite a few questions coming on red clover, so I'm going to switch to red clover. We should also say Heather is also in the room as backup. So if you hear a different voice, it's Heather from the Grafton Development Centre. So an easy one, when is the best time to cut red clover?
Same as you've got.
In a mixed sward, I think you'd be driven by the heading date of the grass after the red clover, certainly after its establishment is for optimum fermentation and also silage quality.
So it's the grass that drives it, not necessarily the point of flowering of the red clover.
If you have a mixed sward, which most farmers would have a red clover lay, in practical terms, that would be the best time to cut if you're going for optimum quality.
But if you have a pure sward of red clover, then you're looking at the bud stage. So you're not waiting until it's flowered, by which time you start to affect protein levels. So you want to, in a pure sward, go for that growth stage. But it is always one of them will always be compromised in the mix.
And two questions really on fertility. One which is just to clarify in terms of sheep. So how long should they be off that red clover mix before and after topping?
All of the advice is 6 weeks before and 6 weeks after, which is quite a long time period. There has been relatively little research done on how much you can change that now. I know a lot of this work dates back to much earlier varieties of red clover, and there's been very little research on the new red clover varieties in terms of how they then respond. Certainly, the advice is to err on the side of caution and stick with the 6 weeks until we know the answer to that.
It's also quite interesting for people to think about ewe lambs, so managing ewe lambs, grazing red clover, if they're potentially on a fattening sort of trajectory, but actually then all of a sudden go to breeding. So what is the impact of ewe lambs grazing on it prior to breeding?
There's different reports on that. Which probably comes down to varietal differences in red clovers and seasonality. The main reason why red clover is impacting on fertility or indeed reproductive development in, say, your younger ewes is the presence of phytoestrogens. So these are estrogen-like compounds which are present in red clover, and they tend to differ throughout the season, and they also differ according to cultivars. They differ according to whether the plant is slightly stressed. So we need to, we really need to be able to understand the key triggers for how they differ and how we can have varieties that don't create those responses before we can say that they're going to be safe.
And is there any clear evidence in terms of red clover affecting cow fertility?
Again, the jury's out on that. There is evidence to show that cattle even fed on red clover silage had reduced fertility, but then I've also read probably more, if not an equal number, of reports stating no adverse effects. So there really is a lot of variation in the literature in terms of whether it's having an effect.
And another question again on the red clover theme. So should cereals be fed to lambs while grazing red clover to provide a more balanced diet or not? This is, can't quite express furrowed brows.
This depends on the level of grass in the mixture. So if it's a red clover lay where the red clover is dominant, then there is more likely to be an energy deficit than if it's less dominant.
As a pure red clover?
No, as a lay.
Oh, right.
In many farming situations we have red clover lays.
Mm-hmm.
So where there's a high proportion of grass, maybe the need for supplementation of cereal or something would be less. Okay. We are moving swiftly along towards bird trefoil, the infamous bird trefoil. So my question is, if there's challenges, how did you manage to grow it for 3 grazing seasons?
I don't even tell you, I grow it organically. We did grow it organically. I used a lot of P&K. Made sure the P&K of the soil was completely correct, so the right indices of that for a legume. pH was increased, which is to make sure it was optimal for it. What I didn't manage to do was get it to persist each year, so I re-established each year. So because I had the advantage of being able to sow each year, which obviously isn't practical, it was for experimental reasons, that wouldn't make it, doesn't overcome the agronomic challenge of it being grazed out very quickly. You'll notice that the experiment was 5 weeks long. That's when the trefoil ran out. Okay. So it's very low yielding.
I was talking to an American researcher who was using it in Utah on really high pH soils and seemed to be getting quite a lot of good results on that with beef cattle.
Yeah.
Any thoughts? Why high pH soils?
Could it have a competitive advantage over its companion grass?
Probably. Nothing else grew, I think. Is that the solution?
That is why it thrives on low fertility situations where...
But it also thrives on acidic soils, so it's interesting with that diverse.
But the companion won't.
Yes.
And do you know of is there any breeding programs out there that are trying to improve it? Because it seems quite an interesting crop, but we can't actually grow it.
Yes, we are in fact conducting improvement work at IBERS in our Phytoestrogens part of the plant breeding program with them.
And so is that, and you're trying to breed bird trefoil that works on classic UK soils, or does it have a preference for soil type?
Well, obviously we're looking for ones that will grow and persist under UK conditions, and we're also looking at ones which, I'm going to get this wrong now, put out rhizome. Yeah, so they have better roostering system which will allow them to overwinter much better and survive that winter period, which is the key reason why it struggles.
So if we just moving swiftly on to lucerne, we also talked about that. So I'm guessing that West Wales isn't the ideal site for lucerne.
It's not typically, but but we use a seed inoculant because it's not that prevalent here, and we also make sure that the soil pH is optimal for it, and we've certainly grown it very successfully here, had very good responses to it growing, and in fact we've looked at it in mixed wards with red clover, and what we found was when we did get a particularly dry summer or a particularly dry spell, then it was able to really demonstrate its benefits over red clover when the weather decided to show a different side to a wet summer.
We've got, just to go quickly back to red clover and just the fertility issue. So the question is, if the red clover lady has 50% red clover, 50% white clover, and grass, which means, anyway, there's some grass in it, at what level does it start to cause infertility issues? And anyway, I'll ask the next question in a moment. The anecdotal suggestion was saying about 40% dry, of when red clover is about 40% of dry mass intake is when you start to get issues, but there's no science behind that. That's just a rough recommendation.
It was only, as I said earlier, that the concentration in that proportion would be probably due to variety and the site and the conditions at that time, and also potentially the different breed of sheep or cattle that's on it, or the growth stage that it's at. Are we giving it too much of that bad press here?
And also the challenge is that you might look down and go, well, it's a low level of red clover, but the sheep can actually select. So if you have a preference for red clover, they will keep selecting it.
Yeah.
So we err on the side of caution.
The science really isn't there, and this is a real limitation at the moment. We've had reports in from the farming industry that they are grazing ewes on red clover over that critical time and not having any issues, and then we have people that do run into problems from doing it. So we'd really like to try and get to the bottom to really understand it.
And there's like a sub-question to that, which is, if the red clover is topped, but does it lose its infertility properties?
No.
So you're just basically reducing the amount that's available. That's what you're trying to do. So you're not. Well, I suppose the next question is, so in red clover silage, would you still have the same fertility issues that you see in fresh?
It can transfer into that. You still can have the presence of the phytoestrogens in concentrations to cause problems in silage, but there's also, again, papers out there that show you can feed red clover without fertility issues, and that is
potentially by topping it, you might stress it, which actually could result in higher concentration.
But also the key thing is that it's red clover silage being fed at tupping time. So if red clover silage is being fed at lambing time, there is no consequence.
There is no issue. No, it's only that critical time period, and I hope I've demonstrated the benefits of feeding red clover to our lambs.
On that point, would lambs finish indoors on good quality red clover silage, or would they require additional supplementation?
Given that we have growth rates of 135 grams per day over that winter period on a red clover silage with no concentrates being fed, obviously it would depend on whether how you're wanting to do or store your lambs, but certainly that is above a live weight gain that people would expect to store winter lambs. So yeah.
So we're now moving into the world of something that we didn't talk about, which is plantain. So one of the questions here is, it also appears to have an amphelmintic effect, similar to chicory. Is there any evidence of that?
It does, certainly does. There's not much work been done in the UK on this, so I don't know how well it transfers across to our sheep breeds and certainly maybe the parasite species that are more dominant here in the UK. But plantain, similarly to the chicory and the Burset trefoil, contains compounds that have amphelmintic effects. It does, excuse me, it does also have the slight downside to that, which is palatability with it, because it contains these compounds in slightly higher concentrations. So the research wasn't supporting 100% inclusion of that in the diet, which you can get away with chicory and the trefoil, so just be aware of that.
And The other question is this sort of idea that we've discussed very much of them being used individually, but actually what is the benefit of them being used together? So the question, which is plantain, clover and chicory together, what could the advantage of that mix be?
Well, obviously the benefit would be that you'd be bringing together all of the production benefits of all of those. The challenge we have in the research is we're always trying to answer a specific question, so unless it is a pure sward, then we can't say categorically, yes, the chicory did have an effect on parasites, but now we've done that foundation work, then very much so looking at the benefits of a mixed sward containing a range of these forages on animal production and health would be a key step.
And in relation to another question, which is an organic farmer here already uses a lot of red clover, so what other plants could be suited into an organic system? So what are the up-and-coming plants, do you think?
Well, lucerne is the most obvious one to include as part of that as a consideration. Within the organic systems, the chicory would have a place as well, although obviously it's not nitrogen fixing, so there would need to be appropriate nutrient management for that. Heather, would you like to comment on organic? Sorry, agree with it.
Well, making strategic use of white clover maize within a system with red clover maize in rotation. It's not a new crop, but it's not being picked up. Oh, you're not being picked up. Okay, strategic use of white clover maize in rotation with red clover maize. I know it's not a new crop, but making the most of a red clover in the organic system depends on being able to break it with crops like white clover or lucerne. And I know you're a fan of lupin. Just talk us through that.
Well, we are obviously looking for alternatives to importing the soya and the issues that I covered on that. The value of lupins is they probably are the only equivalent to soya in terms of both protein and energy that they contain. So we're talking, I must clarify, I'm talking about the lupin grain here. So I've focused very much on forages till this point, but I'm very much talking about lupin grain. Harvesting lupin grain has a high protein and a high energy. So some of the varieties, we have a yellow lupin that can produce up to 45% crude protein content, or we have a narrow-leafed lupin which has about 30%, and then we also have a white lupin which is intermediary. And we've been looking particularly at the spring-sown ones, which is the narrow-leaved and yellow, and looking at how they can be incorporated into ruminant diets as an alternative to soya. So short-term studies that we've undertaken so far, one example would be with finishing lambs again. We grew and dried the grain from the lupin, from yellow lupin and narrow-leafed lupin, and then actually incorporated that into a pellet and compared pellets which incorporated soya at an equivalent inclusion rate, and also compared those to a standard off-the-shelf lamb finishing diet. Showed that for finishing lambs, you could use lupins without any detrimental effects on performance or on their carcass grading. So certainly the potential is there. The lupins do have a way to go again in terms of a breeding program. We don't currently have the breeding work it very much needs to increase the yield, because although it's very high protein yield, very high protein content, the yield is low. So that is work that we do need to do, but certainly there's potential there if we can do that.
And the next question is also about sainfoin as a potential.
Yes, sainfoin is a potential. It's similar to lucerne in that it prefers high pH soil. It's not as high yielding as the red clover and lucerne, and you probably only get 2 as opposed to a 3-cut silage of that. Sainfoin is of interest because, similar to birdfoot trefoil, it contains condensed tannins, which have the ability to not only protect protein but also reduce the parasites as well.
But both, my understanding is both lupin and sandpoint have issues in terms of growing them, which is quite a fundamental bit.
It is a fundamental bit, and it's a bit of a chicken and egg. We have to demonstrate through the research that these novel feeds are viable as an alternative to soya, and then we can create the need for them, and then we have to be able to demonstrate the research to actually get that agronomic improvement. We did have a DEFRA-Link funded lupin project where we looked as part of what the ruminant research I was doing. We had a breeding program associated with that, and we managed to obtain up to 37% improvement in yield just over that 5-year period that we had funding to do so. So there's a lot of scope there, there's a lot of potential, just needs the research.
And I appreciate you were talking about grain lupins, but in terms of whole crop, is that an option as well?
It is an option. I know this has been done on farms. When we did it experimentally, we did find there were some rejection issues with the Untitled lupin. And in terms of the nutritional value, the real value of lupin is in the grain. So that if you're going to get a concentrate alternative to soya, then it's the grain lupin, not the forage feed.
And my current obsession is with annual clovers. So is there annual clovers that we can use more effectively in our systems? So crimson clovers, for example? Yes.
Yeah, they are an option, but I think you have to, from a farming perspective, appreciate that they are annual crops, and then we have to make sure that they're cost effective.
So it's potentially something to fit into arable rotation, certainly not for all systems, but they can work in certain places.
Or they could be part of a pioneering pioneering crop in a longer term lay where they then don't persist for the length, the duration of the lay.
And thank you. And we've got the last question, which is sort of combining it all really. So how does sort of the grazing strategy fit also into your parasite control? So maybe talking on the grass side a bit more, but is there evidence of different grazing strategies affecting parasites?
Yes, certainly there is, and that this is actually mostly to do with mixed grazing or rotational grazing. I mean, it was generally thought for a long time that these grazing strategies weren't that relevant in the UK because of our wet climate. The parasites were able to kind of overcome this, and particularly only in dry regions that the use of rotational grazing was actually effective. But we did a study where we looked at comparing rotational versus set stocked grazing for parasites, and we actually found that even just with a 3-week rotation, so you were actually breaking off for 3 weeks to come back, we had a significant reduction in parasites. So there is a place for it. The challenge is that pasture management and controlling forage quality tends to take priority over parasite control when you're making decisions about when to graze or shut up fields.
I've taken it back. This is the final question. From Mark, which is, I've seen a price of £249 per kilo for birdfoot trefoil seed. What is the sowing rate?
Okay. Well, it's certainly not going to be economically viable at that, I would imagine, in a pure sward. So probably we'd need to look back to the previous question, is how can we put it into a mixed sward and see the benefits of it